All right, let's talk about completing the square. So there are a few different reasons why you'd want to complete the square. First thing we're going to look at is completing the square is a helpful way for turning your quadratic equation from standard form into vertex form. All right, so the reasons why you might want it in vertex form is so that you can easily tell what the vertex is. In standard form, there isn't a clear way without solving the equation. So in vertex form, when it's written like this, the vertex presents itself as the point h comma k. So there you go. Once it's in this form, you can just read off the coordinates of the vertex. There's the x coordinate there, and here's the y coordinate there. So there's the x and the y of the vertex. Okay, so let's check out an example. Okay, so say we had function f of x equals x minus 2 squared plus 4. So if you have your equation written like this is already in vertex form, and we can tell that the vertex is just 2, 4. All right, and something that may be a little more tricky is say you had f of x equals 3 times x plus 2 squared minus 4. So note that in the vertex form, we need it to be x minus something. So if it's not, so if you don't have the x minus, then the h value is actually negative there. So the vertex would be -2, -4. So remember the vertex form is ax minus h squared plus k. So for the k value, we just take this value here at the end. Easy enough. But for the h value, you have to kind of switch the sign if you want to think of that. So here it was a +2, so the h is a -2. Here it was x minus 2, so the h value is actually a 2. All right, so let's check out an example when we have it written in standard form, but we want to get it into vertex form, and that will require completing the square. Okay, so let's start with an example here. F of x is equal to 5x squared plus 40x plus 1. Okay, so this is not in vertex form, and it's not already a square. So the first step is to, if the leading coefficient is not a 1, like in our case it's a 5, we're going to need to factor that out. So we're going to make this 5, and we only factor out of the first two terms, x squared plus 8x plus 1. So notice that we can't really factor a 5 out of the 1 here, so we just don't bother. So that might be a little different, but we can't factor a 5 out of the last term, so we just don't bother with it. We really focus in on the first two terms. Okay, so let's see. It's not in vertex form yet, because over here in this piece here we want to be a square. So it's not a square right now, but we can fix that. So in other words, we want this to be something like x, maybe plus or minus something squared. So we want that x, say, plus or minus something is equal to x squared plus 8x, and then there's probably going to be something over here too. So we're going to try to write it as a square. Okay, and the rule here that, and I'll show you, we'll see why this works, but you're just going to take half of that term on the x. So the term on the x is an 8, so we're just going to take half that. And we'll also take it to have the same sign. So in other words, write this down. So x plus 4 squared, so that's half. Half of 8 is 4. So x plus 4 squared. And if you multiply this out, you would get the two middle terms would be plus 4x plus 4x. So distribute that out, and you'd see that the middle term would get 8, would be an 8x. Right? What I'm saying is if we wrote this out like this and we FOILed, we would get x squared plus 4x plus 4x plus 16. So, so that's what we're going to want to do here. So we're going to take x plus 4 as our square. So x plus 4 squared is equal to x squared plus 8x plus 16. Okay, so we're going to want to put the x plus 4 inside here. So I'll show you how to do that. All right, so in other words, we want to make this 5 times x plus 4 squared. Actually, let's write it like this. Right now it's x squared plus 8x. So equivalently, we could write that as x squared plus 8x plus 16 minus 16. So we cleverly added 0 right here. That's just adding 0. We can do that. That's not going to change anything. Notice notice that it was done inside the parentheses because we still have the 5 factored out. So, and the reason why we did that is because now we know that this piece right here, that's just x plus 4 squared. Now I have this minus 16. So we didn't have a square on the inside, and we cleverly added 0, and then we were able to write the square, and now we have a constant term out here, the minus 16. So we can collect all of our constants together. Now we have 5, and we'll write x plus 4 squared, and now we need to distribute 5 times negative 16. So let's see, 5 times negative 16. Let's see. So it's like 10 times 16 would be 160. You can divide that by 2. So that would be negative 80. And then we have plus 1. All right, so now we have our slope, or sorry, our vertex form right here. So it's 5 times the quantity x plus 4 squared minus 79. So we conclude that our vertex is 4, comma, negative 79. Actually, it should be negative 4, right? Because we kind of take the opposite sign for the h. And that's it.